Okay. Obviously, things are getting a little bit more serious when we're looking at exponents. I'm going to just rewrite it to make sure that there's a common understanding. So I believe that this says 7 to the power of 2/3 divided by 7 to the power of 1/3 times 7 to the power of 5/3, all to the power of 6. Ask yourself, what should I do first? Okay. For example, I'm going to do this two ways. I think I would personally tackle the denominator first. 7 to the power of 1/3 times 7 to the power of 5/3 is 7 to the power of 1/3 plus 5/3. So now I have 7 to the power of 2/3 over 7 to the power of 2, all to the power of 6. Now, I don't want to lose you, so I'm going to have to do a lot of rewriting here, right? And now I would use the quotient rule. And the quotient rule just simply is, I'm going to try to get that up to the numerator. And it's not, I would subtract my exponent 2. There we are. And if I underline this, really I'm dealing with rational numbers, a concept that we've been dealing with for quite some time now. So to subtract those two numbers together, I suppose I need a common denominator. So my common denominator is 3. So there we have it. I think this is looking good. So I have 7 2/3 minus 6/3 is minus 4/3 squared. Oh, sorry. I messed up this exponent. This exponent should be 6 all the way along. My mistake. Now, I know that if I'm using the product law, I need to multiply these exponents together. So it would be negative 4/3 times 6. So really, I would get 7. I'm running out of room again. This is a tough question. So 7 to the power of negative 4/3 times 6 is going to be, I'll try to clean this up, I'm sorry. No, that's an exponent, so I have to make that 7 extra long, times 6. Now it's really 6 over 1, so I have 7 to the power of negative 24 over 3. And this ends up being 7 to the power of negative 8. Now, I believe that's my answer, so let me just check what was required of me. I had to express all of my answers in positive exponents. So this is not a positive exponent, but we're only one step away. So really this is, I would just simply take the reciprocal of the base. So it would be 1/7 to the power 8. All right. Wow. That was hard. Maybe can you see a different way? I'm going to tackle this from a completely different angle, and just to show you, I know what you're thinking at home, probably. Just pick a way and do it. Well, sometimes some ways resonate better than others. You know what? I'm going to do it this way. I'm going to say 7 to the power of negative 2 over 3 times 7 to the power of negative 1/3 times 7 to the power of negative 5/3. That is, I saw a whole bunch of exponents in the denominator. I'm going to bring them up to the numerator just by making them negative. That is, take the reciprocal of them. All that to the power of 6. Now, it's really 7 to the power of 2/3 minus 1/3 minus 5/3, all to the power of 6. So I'm dealing with that exponent. So negative, or 2/3 minus 1/3 minus 5/3, really that's negative 6/3 minus 2. So I have negative, or 7 to the power of negative 4/3. All that to the power of 6. And now this actually might have been an easier way. But there's more than one way to do it. That's what you have to keep in mind. There. I got the same answer. All right. Please make this madness end. Unfortunately, it's not. So let's take a look at what we got going here. And it's really important that we're going to look at the constants separately, and then we're going to look at the a's separately, and then we're going to look at the b's separately, because ultimately this is just multiplication. So I'm going to say this is 4 divided by 2 times a over 2 over a squared times b to the power of 2/3 over b to the power of 1/3. And I'm hoping you're able to pick this off fairly straightforward. And really, this is 2 to the power of a minus 2 times a minus 2. I have a square in the denominator, so I'm going to bring it to the numerator. I know that this is inefficient, but bear with me. B to the 2/3 times b to the negative 1/3. Now I'm going to add exponents, use my product law. There. I add those two exponents, and this is what we have. Now I'm almost here. I just need to make all my exponents positive. So really, in the numerator, I keep all my positive exponents. And in the denominator, I simply take the reciprocal of a. A to the power of negative 4 would be a to the power of 4. That wasn't so bad. Oh, gross. All right. I'm hoping this is the last example, and it is.